What is the volume of the solid in x, y, z space bounded by the surfaces y is equal to x squared, y is equal to 2 minus x squared, z equals 0, and z equals y plus 3? One of these 5 numerical options. Okay. Well, should we sketch something? I'm usually a strong advocate of drawing a picture to better understand what's going on. We'll say that Z is going in like that. Maybe let's first understand these other regions. So I have x squared. I have 2 minus x squared. So those will intersect when x is equal to 1. So those are surfaces, right? And then I have sort of plane here. And what shape? Okay, so if I draw my z-axis out like that, I don't really like, I don't like the way I do this. As z increases, y, oh man. Sheesh. Sorry, where's my head here? So for this last plane, z is equal to y plus 3. So z is equal to 0, sort of the front thing here. And z is equal to y plus 3 is going to give a plane. So how about I figure this out? When y is equal to 0, z is equal to 3. So this plane kind of stretches like that. Will this be easier if I just write out the 3-dimensional integral that gives me what I want? Or maybe I can write it as a 2-dimensional integral. Oh, I didn't expect a question to trip me up so much at this point in this exam. Okay. I think it'd be pretty difficult to figure out geometrically how to do this. So maybe I'm just going to try and write this as an integral and just evaluate it. Okay. I don't think I needed to work out. This took a lot longer than I thought. But let's figure out. Let me try and explain what my thought process was. Fiddling around too much with integrals like this, I don't think is the way to go. Although I suppose it would get you there eventually. Understanding the geometry of the problem a little bit better helped. And it appears that I think something happens with the way these surfaces slice each other that I didn't think was actually going to happen. But it does, and it simplifies things. So looking flat on at this solid looks like that. And so the solid kind of continues into the screen. So the surface area of this thing is 4/3. That's really easy to compute. It's just an integral. And then what I'm going to do in going from this diagram to this diagram, I'm basically rotating my view so that this surface, that area, is now, that's like what we would see if we looked on in this direction. Okay, so that this surface area right here, that's that face. Okay. Now the other two planes dealing with the z direction, this is the z equals 0 plane, and this is the plane z is equal to y plus 3. So this area is then being, that area corresponds to an entire volume here. And so I'm just taking this area and multiplying by this distance 3. So the volume the volume of the shape contributed by this region is equal to 4. That's there. And then things get a little bit complicated where, because this plane is now slicing through this area at certain places, but because what happens here is because this area is symmetric, symmetric around that line right there. So this line right here, or where this plane here will slice through the halfway point here, right there. And so any volume, if I figured out, if I didn't have this plane, if I just said that Z was bounded between 0 and 5, then I would just take this area and multiply by this entire distance 5, and that would give me this whole volume. Okay, but there's a piece missing, and the piece missing is this one here. That piece is missing. But what's important to realize is that the volume of the missing piece here is the same as the volume of the piece that is included here, and that comes from the symmetry of this shape. For some reason, I didn't think that was going to be the case. When this straight plane is intersecting this curved surface, I thought it was going to be of a different nature than when it intersects that curved surface there. So anyway, I have 4 over 3 multiplied by 3. That gives me the volume corresponding to there. And then I have the area 4 over 3 multiplied by this distance of 2. But I only want half of that. I only want the upper half of that whole thing. So I'm again dividing by 2, and you work this out, it comes to 16 over 3. Pretty sure that's the right answer, but if that's not correct, then I'll make sure there's a comment down in the description. This one took a lot longer than I expected, but hey, that's how it is sometimes. Thanks for watching.